Given that x squared plus 3xy plus 2y squared minus 2x equals 13, find the value of dy dx at the point 1, 2. And given that x equals 2e to the t plus 6, y equals 4e to the 2t plus 3e to the t plus 1, find the value of t when dy dx equals 6, giving your answer correct to 3 decimal places. So I've got the summary of the questions above. So let's have a look at part A then. We just need to differentiate this, run along the row term by term. It's an implicit function, so let's just differentiate this then. Power of x, 2 comes down as x to the power 1 less, so that's x to the 1. This is a product, so it's u dv dx, which is dy dx, of course, plus v, which is the y, times the 3x differentiates, which differentiates to 3. Next term, again, this is a function of a function, so to speak. The power 2 comes down to be with the other 2 to make 4, y to the power 1, multiplied by the something differentiated, which is dy dx, because the something is y. Minus 2 lots of x goes to 1, so that's minus 2, equals, and the constant differentiates to 0. So I'm going to simplify this now, before I put in the values, because it just seems to me to be the best thing to do. So we've got 3x here, we've got a 4y to the power 1, that is, so I'll just leave that as 4y. So 3x plus 4y dy dx on this side. I'll move everything over the other side, isn't it? So the 2x can go over. The 2 can go over first to become plus 2. Then it's going to be minus 2x. That's that one done. And that one moved. And then the 3y, move that over as well to minus 3y. So that tells us then what dy dx equals. So why don't we get that? Even though we're not asked explicitly to do that in the question. It's 2 minus 2x minus 3y over, I move this from times down to divide, 3x plus 4y. There we go. So, at what point have we got then? Let's have a look at the question. At 1, 2, dy dx equals then. So x is 1, y is 2. So x is 1, y is 2. So we get 2 minus x is 1, that's 2 then. 2 times 1 is 2. Y is 2, so that will be minus 6. Over 3x, x is 1, so that's 3. 4 2's, because y is 2, is 8, so that's 3 plus 8. So 2 minus 2 is cancels, minus 6 over 11. So there's our dy dx then, minus 6/11. So that's part A. Now part B. So look at that then. X and y. Find dy dx. Find t when dy dx equals 6. So we need dy dx, don't we? So let's turn our attention to this. dx dt first of all then. Differentiate with respect to t. E to the t goes to e to the t. So it's 2 lots of. The constant goes to 0. dy dt. Let's get that. So this is a function of a function. E to the something goes to e to the something multiplied by the something differentiated. So a 2 comes down to be with the 4 to make 8, e to the 2t. And then this, 3 lots of e to the t differentiates to e to the t, and there's 3 lots of it. And the constant goes to 0, so that's dy dt. So let's get dy dx then, which is equal to dy dt divided by dx dt, which equals dy dt is 8e to the 2t plus 3e to the t divided by dx dt, which is 2e to the t. So that equals 6, doesn't it? And we need to solve for t. So there's an e to the t common all the way across the top and bottom of this fraction, because this e to the 2t is none other than e to the t squared. So I'm going to take an e to the t outside the bracket. Inside there'll be 8e to the t. So can you see that would be 8e to the t times e to the t, which would be e to the 2t, plus 3 on the top, over 2e to the t equals 6. Now we can cancel common top and bottom. The whole of the top and the whole of the bottom it needs to be, of course. So move the 2 up to be with the 6. So we get 8 e to the t plus 3 is equal to 2 times 6 is 12. So what have we got then? We're nearly solving the problem now. Let's move down just a smidge more. So that tells us then that e to the t is equal to 12 minus 3 is 9, and then move the 8 down, 9 over 8, and then we can just take logs now. So t, basically making this a log is you just drop the e, you swing it down underneath and bring it here. So it's log e of 9 over 8. So there's t, and we need to tap it into 3dp, don't we? So it's the natural logarithm of 9 divided by 8. The 3dp we wanted, don't we? 0.118. 0.118.